Welcome to the HVAC pumps module. In this session, we will dive into the essential role that pumps play in HVAC systems. From enhancing the flow of fluids to optimizing pressure, pumps are key components that ensure efficient operation in various applications. Whether you're new to the field or looking to expand your knowledge, this module will provide you with a comprehensive understanding of the different types of pumps, their functions, and how they are used in HVAC systems. Let's get started. Let's begin with a fundamental question: what is a pump? A pump is a machine designed to transfer mechanical energy to a liquid, increasing its flow rate and static pressure. This process is essential in numerous applications, from circulating water in HVAC systems to transporting fluids in industrial processes. Pumps are broadly classified into two main types. Positive displacement pumps. These move a fixed amount of liquid with each cycle. Perfect for applications requiring constant flow despite pressure changes, such as gear pumps, diaphragm pumps, and piston pumps. Dynamic pumps. These rely on adding energy to the liquid, increasing its velocity and converting this into pressure. Ideal for higher flow rates, with examples including centrifugal pumps and axial flow pumps. Let's talk about the different types of pumps and how they work in various applications. First, we have dynamic pumps. These pumps add energy to the fluid to make it move faster, then convert that speed into pressure. They're great for situations where high flow rates are needed. Centrifugal pumps are a classic example. They use a spinning impeller to increase fluid velocity. Then there are mixed flow pumps, which combine features of centrifugal and axial designs. These handle medium flow rates and moderate pressure. Lastly, axial flow pumps push fluid straight along the shaft and are perfect for very high flow rates at low pressure. Next, we have positive displacement pumps. These work differently because they move a set amount of fluid with each cycle, no matter the pressure. Reciprocating pumps use pistons or diaphragms to push the fluid, making them ideal for high-pressure jobs. Rotary pumps, on the other hand, use rotating parts and are great for moving thicker, more viscous fluids. Finally, we have special effect pumps, like jet pumps, electromagnetic pumps, and diaphragm pumps. These are designed for specific tasks and can handle unique challenges. Let's talk about dynamic pumps. They're all about giving energy to a fluid so it moves faster and builds pressure. Here's how it works. First, the liquid gets pulled into the center of a spinning impeller. Then, as the impeller spins, it flings the liquid outward, speeding it up. Now, when that high-speed liquid hits the pump casing, some of that speed gets converted into pressure. And that's how the fluid gets pushed through the system. A couple of things make a difference with these pumps. The impeller design. This affects how fast the fluid moves and how efficient the pump is. And the number of stages. If you need more pressure, a multi-stage pump adds extra energy to the fluid. So, by understanding these features, you can pick the right pump for whatever job you've got, whether it's pumping water, chemicals, or anything else. Let's dive into positive displacement pumps. These pumps are all about moving a set amount of liquid every time they operate, whether that's with a stroke or a rotation. What makes them special is that they deliver the same amount of fluid, no matter how much pressure is in the system. There are two main types. Reciprocating pumps. These use a back and forth motion, like a piston, to push the fluid. They're great for high-pressure jobs. Rotary pumps. These use rotating parts to trap and move the liquid. They're especially good for steady flows and can handle thick, viscous fluids with ease. So, if you need consistent flow and reliable performance, positive displacement pumps are a go-to solution. Let's talk about centrifugal pumps. They're one of the most commonly used types of pumps. These pumps work by using a rotating impeller to move fluid. Essentially, they take rotational energy and turn it into hydrodynamic energy to get the job done. Now, depending on how the fluid flows through the impeller, we can break them down into three main types. Radial flow pumps, these push the fluid outward, making them great for applications where you need high pressure but lower flow rates. Axial flow pumps, these are designed for high flow rates at low pressures, as the fluid flows along the pump's axis. Mixed flow pumps, these combine elements of both radial and axial flow, which makes them perfect for medium flow rates and pressures. Each type is suited to specific needs, so selecting the right one depends on the application. Let's dive into reciprocating pumps, a type of positive displacement pump that uses a back and forth motion to move fluids. These pumps are great when you need precise and consistent fluid delivery. There are three main types to know. Piston pumps, these use a piston inside a cylinder to create suction and displacement. They're perfect for high pressure jobs. Plunger pumps, similar to piston pumps, but they use a plunger instead. These are built for high performance and durability. Diaphragm pumps, these use a flexible diaphragm to move fluid, making them ideal for handling aggressive or hazardous liquids safely. Reciprocating pumps also come in two configurations. Single acting, these displace fluid on the forward stroke only. Double acting, these displace fluid on both the forward and reverse strokes, which provides a smoother, continuous flow. Thanks to their precise delivery and ability to handle high pressure or viscous fluids, reciprocating pumps are a go-to choice in many industries. Let's explore rotary pumps, another type of positive displacement pump known for their smooth and continuous flow. These pumps work using the meshing action of gears, lobes, screws, or similar components to move fluids. Here are the main types of rotary pumps. Gear pumps, these use meshing gears to trap and move fluid. They're great for viscous fluids and high-pressure applications, providing a steady and reliable flow. Lobe pumps, with rotating lobes, these pumps are perfect for handling liquids containing particulates. That's why you'll often see them in food and pharmaceutical industries. Screw pumps, these pumps feature a rotating screw element that pushes liquid through. They're ideal for high viscosity fluids and provide a continuous, low pulsation flow. Thanks to their ability to deliver precise and consistent flow with minimal pulsation, rotary pumps are a top choice for applications where accuracy and control are critical. Let's understand the types of pump operation. This image illustrates the two main types of pump operation, operating in series and operating in parallel. In the operating in series configuration, the output of one pump becomes the input for the next, increasing overall pressure or flow rate. In the operating in parallel configuration, pumps are connected to the same inlet and outlet, dividing the flow and potentially increasing overall flow capacity. Understanding these operation modes is important for designing and configuring pump systems to meet specific application requirements. Pumps are all about keeping liquids moving smoothly and efficiently, no matter the system. Here's how they help. Moving liquids, whether it's water, oil, or chemicals, pumps are the workhorses that transfer liquids from one spot to another in homes, industries, and businesses. Lifting liquids, ever wonder how water gets to the top floors of a building or uphill to a storage tank? That's a pump working hard to move liquids against gravity. Boosting flow, in systems like cooling circuits or HVACs, pumps make sure there's enough liquid flow to keep things running efficiently and effectively. Basically, pumps are the heroes behind the scenes, making sure liquid systems do what they're supposed to. Early pumping systems. Before modern pumps came along, early pumping systems were simple mechanical tools that moved liquids using basic power sources like human effort or animal strength. They were essential for farming, mining, and getting clean water. This image illustrates three ancient methods for moving water. Chain of pots. This system utilizes a chain of pots that are attached to a wheel. The wheel is turned by hand or by an animal, causing the pots to dip into a water source, fill with water, and then be lifted up to a higher elevation. This method is simple but inefficient. Noria. A noria is a water wheel with buckets attached to its outer rim. As the wheel rotates, the buckets scoop up water from a lower level and carry it upwards. This method is more efficient than the chain of pots, as it can move larger volumes of water. Water wheel. This system involves a large wheel with paddles attached to its rim. The wheel is turned by the force of a flowing stream or river, which pushes against the paddles. The rotation of the wheel can be used too. We appreciate your time and engagement in exploring the vital role of pumps within HVAC systems. We hope this session has provided you with valuable insights into their types, functions, and applications. Your commitment to learning is inspiring, and we're excited to continue this journey with you. In the next session, we are going to discuss HVAC source equipment for cooling.